Alright everyone, welcome to the first set of home notes for Algebra 2 Core's Sequence and Series unit. So our first section is called What is a Sequence? So we have some vocabulary terms. So a number sequence is a list of numbers defined by a rule. So if I tell you that a list of numbers is defined by the rule 2n, then my list of numbers would be 2, 4, 6, 8, 10, 12, well, it's just going to keep going. So ... A term is a single number in the sequence. So 8 is a single term in this sequence. It's the fourth term, actually. A finite sequence is a sequence that terminates or ends. So you see how this sequence here ends. It stops at 14. It doesn't keep going. An infinite sequence is a sequence that never ends. So it has the same 5 numbers, but after 243, it has this comma, ... Now this is an ellipses. I know some people use them in text messaging to kind of express that there's more going on behind what you said. So you might say, I can't believe that happened, ... or I went to the grocery store, ... because it means that there's something else going on. So there's the difference between finite and infinite. Our big vocabulary terms for this section is arithmetic and geometric. So an arithmetic sequence is a sequence that goes from one term to the next by always adding or subtracting the same value. For example, given my sequence 1, 4, 7, 10, 13, 16, if I go through and look, 1 to 4, I'm adding 3. 4 to 7, I'm also adding 3. 7 to 10, you guessed it, still adding 3. 10 to 13, adding 3. 13 to 16, still adding 3. And because this is a sequence, this pattern is always going to hold because it's an arithmetic sequence. And my pattern started with adding 3, it's always going to be adding 3. So my next term will be 19. And then after that will be 22 and 25, and so on and so forth. It gets very exciting. Geometric sequences are a little bit different. So a geometric sequence is a sequence that goes from one term to the next by always multiplying or dividing by the same value. Okay, so look at this example. It says 2, 4, 8, 16, 32, 64. If you guys remember 2 other units, you'll recognize that these are powers of 2. So each time I'm multiplying by 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. And 32 times 2 is 64. And then I know that, well, this one ends. So there's really nothing left to this. It's a finite sequence. It stops there. But I know the pattern. If I wanted to continue it, though, if I was like, well, what comes next? I would just do times 2, and I'd get 128. And then times 2 with that, and I get 156. Not 156, 256. But you guys get the picture. So then our big question is going to be, is a sequence arithmetic, geometric, or neither? Well, if a sequence is arithmetic, there should be a common difference. This is a really important idea. If a sequence is geometric, there should be a common ratio. And if a sequence has no common difference or ratio, then it is neither arithmetic or geometric. So we can use this idea to figure out if a sequence is arithmetic or geometric. And you gotta kind of think of what it means. Okay, common difference, common ratio. Okay, if there's a common difference, well, let's subtract the terms and see if the difference between the terms, consecutive terms, is the same. A common ratio, well, let's find the ratio between the terms and see if that ratio is the same. Let's try some problems now. So guided practice. In A, it says determine if the sequence is arithmetic, geometric, or neither. Okay, so it gives me 28, 36, 44, 52, 60. Okay, well, let's look at this and think. Okay, is there a common difference between these numbers? Well, let's try it. Let's do 36 minus 28. You get 8. Okay, let's try it with another one. 44 minus 36. You also get 8. Okay, let's jump around a little bit. Let's do 60 minus 52. What do I get? Well, I get 8. Okay, I think we've sufficiently figured out that it is, in fact, an arithmetic sequence because it has the common difference of 8. So let's say that. Arithmetic, common difference of 8. Okay, that's kind of cumbersome to write common difference of 8, but let's just do that for now. But it's definitely arithmetic because I was adding the same number each time. All right, what about the next one? Is this one arithmetic, geometric, or neither? Okay, let's try. All right, so 2, 6, 18, 54, 162. Well, when I look at this, I can kind of see that there's not a common difference, but let's check. Let's do 6 minus 2. I get 4. Let's do 18 minus 6. Well, that gives me 12. Okay, these aren't the same, so there's no common difference. No common difference. Okay, no common difference here. Right, and it's very important that you use consecutive numbers. Okay, so don't do 54 minus 6. Always do 6 minus 2. 18 minus 6. 54 minus 18. It's consecutive numbers that you have to do. Right? The other one is geometric. Okay, so to check if it's geometric, we want to find the common ratio. Remember, ratios are like little division things. Okay, so let's find it. Okay, so you do 6, and then the ratio is division, so divided by 2. 6 divided by 2, well, that's just 3. All right, let's try again. 18 divided by 6. Always pick the consecutive one. 18 divided by 6, that's also 3. All right, we're moving right along here. Let's try one more. 54 divided by 18, and that gives me, it's 3 again. Okay, good. So because we have this common ratio, it's a geometric sequence. Okay, it has a common ratio of 3. Okay, so it's definitely geometric. All right, this last problem here, let's go through. Okay, so I got negative 14, negative 6. So let's do that first. Negative 6 minus negative 14. Okay, it's getting a little bit weird with the negatives. I like to throw parentheses in there to make sure it works. Negative 6 minus negative 14, that's the same as negative 6 plus 14, which is equal to 8. Okay, I'm having some flashbacks, but let's just keep going. All right, next one. It's negative 2 minus negative 6. Okay, negative 2 minus negative 6 is the same thing as negative 2 plus 6, which is 4. Okay, because these are different, it's not arithmetic. So no common difference. Okay, let's try for geometric now. So geometric is my ratios. Okay, so I got negative 6 over negative 14. Negative 6 over negative 14, well, that's clearly 3/7. I could make it decimal, but I'm not going to because I know how this turns out. So negative 2 divided by negative 6. What do we get here? Well, this is 1/3. These are clearly different. These are clearly different here. So there's no common ratio. Okay, if there's no common difference and no common ratio, it means it's not geometric and it's not arithmetic. So let's write neither. Okay, after this video, I want you to go to that Google form and try those practice problems real quick. There's some vocabulary in there too that you might need to look at. If you get stuck and you don't know what to do, bring up these notes and look at them again and just think of what you need to do. Thank you guys very much. Good luck on the homework.